first we will try to look at the law, the mathematics behind. Then after that we will try to do some sort of hands-on exercise using Excel. You all have, na? Okay, we will use Excel to calculate the probabilities from the data set. First we will discuss about what is exactly flood frequency analysis. So what is frequency analysis? फ्रीक्वेंसी एनालिसिस क्या होता है? Probability of occurrences of extreme events you are trying to correlate, or you are trying to calculate the probability of occurrence based on their magnitude of different events, है ना? So you have magnitudes of events. Now you are also assigning the probabilities of these magnitude with their probabilities. So that is called the frequency, or that is called the probability analysis. Frequency analysis का क्या मतलब होता है? अगर हम ये बात बोलें कि let's say a flood events which will occur 1 in 100 year, और 100 year flood return period जिसका है, उसका क्या मतलब होता है? 100 साल में एक बार. Is it possible that flood will only come in 100 years? Is it possible that 2 events can be possible? और लेट्स से अगर हम 100 ईयर की बात करते हैं तो फर्स्ट 100 ईयर और नेक्स्ट 100 ईयर में क्या वो दोनों इवेंट्स पास हो सकते हैं? ऑफ कोर्स हो सकते हैं. सो इट इज़ अ काइंड ऑफ अ लाइकलीहुड सिनेरियो. कोई सर्टेनिटी नहीं है कि अगर मैंने बोला कि 100 ईयर फ्लड जो फ्रीक्वेंसी है या मैग्नीट्यूड है वो नेक्स्ट ईयर नहीं आएगा. इट इज़ अ all different magnitude events can be your 100 year flood frequencies. It depends based on your magnitude and their frequency levels, like that. So when you are talking about let's say 50 year return periods, what is 50 year return periods? जो 50 साल में आता है. 10 year return periods जो 10 साल में एक बार आता है. 2 years return periods जो हर 2 साल में आता है. What is that event? That is called median behavior. What is median? What is median? What is mode? What is mean? Mean is the average value. Mode? Maximum occurrences. What is median? Exactly between. Exactly between. So, हाँ, तो मीडियन वैल्यू का मतलब ये होता है अगर तुमने प्रोबेबिलिटी डिस्ट्रीब्यूशन फंक्शन बनाया तो उसके सबसे मिडिल में जो वैल्यू आएगी दैट इज मीडियन वैल्यू. अगर उसमें एक लाइन तुमने खींचा और वो प्रोबेबिलिटी डिस्ट्रीब्यूशन फंक्शन को 2 इक्वल पार्ट में डिवाइड कर दे, दैट इज कॉल्ड मीडियन वैल्यू. आफ्टर अरेंजिंग, यस ऑफ कोर्स, व्हेन यू आर अरेंजिंग द डेटा सेट you are moving from this int to that int and then you are finding the middle point, right? That is how basically it is defined. So basically the frequency analysis is the method where you are trying to calculate the probability of occurrences of each different events with their corresponding magnitude. Once you establish this fact between frequency of occurrences with their magnitude, now the next step would be to calculate what is the magnitude of the flood events which will occur 1 in 100 year. अब इस इंफॉर्मेशन की यूजफुलनेस क्यों है, क्यों हम करते हैं इसको? Why it is required to calculate 100 year return period flood? क्या चीज़ करने के लिए हमें क्यों जरूरी है 100 year flood को कैलकुलेट करना या 100 year ड्राउट इवेंट्स को कैलकुलेट करना? डिज़ाइन करने के लिए, रिजर्वायर डिज़ाइन करने के लिए, इंफ्रास्ट्रक्चर डिज़ाइन करने के लिए, या उस अगर 100 ईयर फ्लड इवेंट्स आता है या 100 ईयर एक्सट्रीम रेनफॉल इवेंट्स आता है तो उस हिसाब से हमें स्टॉर्म वाटर ड्रेनेज सिस्टम बनाने के लिए, ताकि वो इवेंट आएगा तो सारा का सारा पानी इवैक्यूएट हो जाएगा, लाइक दैट. So therefore this is the why this frequency analysis are is very important, and that is why we hydrologists use this kind of analysis for different purposes. So this is we have gone through already. We have also discussed about this graph. These things we have already discussed. Let's go straight to that example. Suppose we are measuring a river discharge for a one particular river basin for 45 years. ठीक है? Since 1950 to 1994, let's say, that is total 45 years of the data set. Now for each year you are calculating the maximum value. अब maximum value calculate करने के क्या तरीके होते हैं? We have talked in the previous lecture. There are two methods. One is block maxima, second is POT, peak over threshold. Block maxima matlab, let's say in this case you are using 365 values. Out of 365 values you are calculating what is the maximum value. So for 1950, 804 is your maximum value. 1951, 1090 is your maximum value. ठीक है? 1952, 1580 and similarly 1994, 348. This is the maximum value. इससे maximum value गई नहीं उस साल. This is the top value for that particular year. Now you have already calculated these values, you have tabulated them according to that different year number. So now this is, you can also plot, this will similar to this curve you will appear, and you can also draw a line. Let's say हमने 1500 पे एक लाइन और 1500 के आसपास एक लाइन ड्रॉ कर दी और उसके ऊपर बोला कि हाउ मेनी इवेंट्स आर देयर दैट इज कैन बी कंसिडर्ड एज एक्सट्रीम फ्लडिंग इवेंट्स. नाउ यू कैन आइडेंटिफाई हियर इफ यू हैव जस्ट मेंशन 1500 क्यूमेक्स इज अ थ्रेशोल्ड where it is classified as a extreme flooding conditions. In that case 1952 can be your one of the year which is extreme flooding event happened in 1952, 1956, 57, 58, 72, 76 and 81 and 87 and 92. These are the years where a flood events were crossing above 1500. अब कुछ लोग पूछेंगे ये 1500 को कैसे हमने कर लिया इसको एक्सट्रीम इवेंट्स. इट माइट पॉसिबल दैट रिवर जो क्रॉस सेक्शन होगा वो 1500 को एक डेंजर लेवल बताता होगा, है ना. हो सकता है कि अगर हमने इस जो ये एनालिसिस की है, लेट्स से यू आर यूजिंग दिस एनालिसिस फॉर वेरी माइनर ट्रिब्यूटरी इन नर्मदा वेयर द फ्लड विल मैग्नीट्यूड विल बी नॉट दैट मच हाई, बट लेट्स से इफ यू आर यूजिंग दिस एनालिसिस फॉर मेन चैनल ऑफ द नर्मदा, ऑफ कोर्स द फ्लड विल बी वेरी हाई magnitude. There the threshold will be very high because bankful condition will be higher values, right? So similarly based on that we have identified this threshold, and based on this threshold we are trying to find out which year your values were greater than 1500 cumex or certain extreme value thresholds like that. Now you have already quantified marked those year where you have observed. Now in this way you can calculate what is the difference between one event to the another event. One event to the another event का मतलब लेट्स से एक इवेंट हुआ है 1952 को, अब इसके बाद दूसरा इवेंट कब हुआ है 56 में, तो इसके दोनों के डिफरेंस कितने हैं 4 इयर्स, है ना. 1952 को अगर हम छोड़ दें 53, 54, 55, 56, it is a 4 years, right? Then there is another recurrence interval is 57, 1, 58, 1. Then there is the next event occurred in 1972, which means the total duration is 14. Then another event appeared in 1976, which means the recurrence interval from 1972 to 76 is 4 years. Then 81, 87 and 92 we have calculated the recurrence interval of these different flood events, and based on that we would be able to calculate what is the average recurrence interval. We can calculate, right? इसको हम जोड़ लेते हैं and divided by how many times it reoccurred? 8 times. We divide by 8 and that will tell you about 5 years. So basically on an average, the flood of 1500 crossing magnitude will occur 5 years in average manner. But we have in the data set, we have already seen there are instances when 14 years long record these flood events were not appeared. But there are instances when consecutive years, for example here you look at 57, 58, 56, consecutive years these events occurred, and there are events where we have 14 years gap like that. So which means this value is just for your interpretation purposes, for average reoccurrence of floods for one particular period. 5 years means these events can occur in 5 years on average durations, but it might also possible that consecutive events can be crossing above that particular thresholds as well. So this is basically sort of a written period of that particular thresholds which we can calculate from the data set. Now you have the Excel data, ठीक है. अब Excel data पे हम एक threshold बना सकते हैं. We can do similar analysis and we can calculate what is the recurrence period of any given threshold. We can change the threshold and we can get the different reoccurrence periods, है ना. And based on that we can make a plot between the reoccurrence period and your threshold values. That will tell you about what is the relationship between the magnitude and their return periods. That is sort of the relationship we can get from the data. Now basically we have got the probability of occurrences of these particular events is 5 years, right? What is the return period formula? जो T होता है ना, return period or probability is inversely proportional to each other. T is equal to 1 by P, P is equal to 1 by T. Okay, so let's say if you know the time period, which is we know that from the data set itself, that is 5 years. Now somebody will tell you about, now can you calculate the probability of occurrence of magnitude which are crossing above 1500 qmax? The answer is yes, because we know that time period T, we can divide 1 by T, 1 by 5 and you can calculate probabilities which is equal to 0.2. ठीक है, 20% चांस है कि जो मैग्नीट्यूड है that will cross above 1500 qmax, like that. Now there is another way of ranking the data set and calculating the magnitude probability of each different event. So जो previous example हमने देखा, इसमें एक problem है. There is one problem is we are not calculating the probability of occurrences of each different events magnitudes. We are only focusing on the threshold, whether it is 1500, 2000, 2500, like that. But somebody can also ask you, right, what is the probability of occurrence of 804? ना, तब तो हम 800 के ऊपर हमें लगाना पड़ेगा threshold, then we can calculate it. So then there is a multiple times we have to apply this whole theory one again and again, then we have to calculate. Is there any other way to calculate the probability of occurrence of individual flood events, and then we can relate with your frequencies with the magnitude, and then we can find out, let's say 100 years or 50 years or more than that return periods, like that? Yes, there is a way we can do that. So there is a probability plotting formula we can use. ये होता है P is equal to the cumulative probability is equal to small m divided by n plus 1. Small m का मतलब होता है ranking. When we are using descending data set, घटते हुए क्रम में, okay. So the most highest value we will give them 1 rank, and second highest is 2, third highest is 3, like that. And that is you called the rank m. N is called the total number of values with your data set. How many value data points you have in your data set, right? So that is n, and then we add n plus 1 here, and you will get some sort of probability number. n plus 1 क्यों कर रहे हैं यहाँ पे? इसका एक reason है. So for example, it might possible that there are very low number and you will get very low probability as well. That is why we are adding here one number here. So for example, this is the case here, the data set you have. in this data set you have the annual maximum value. Okay, now you can arrange this data set. What is the maximum value here? So अगर हम इस डेटा को दोबारा से देखेंगे ना, this is the same data set which I am showing there. So 804, this is the data. Okay, what is the maximum value is 3069 maximum value. So this is your maximum value. I think second maximum is somewhere 1982. Yes, so this is the second maximum. So similarly we can calculate third, fourth, fifth, like that, and we can arrange our data set like that. Okay, so 3069, 18982, 1657, 1651, 42. Similarly we can arrange the data set from the highest to the lowest one, and then we can rank this data set. Okay, that is ranking is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. So I have only written only 10 or 11 numbers. We will repeat this exercise with Excel. Whatever the data set I have shared with you, you can open the data, you can do this analysis here only, and then we will make a plot between the probability of occurrences with the magnitude, and then we can correlate with each other. So here basically we can calculate the rank, assign the rank, and the same formula, this one, m by n plus 1. Here you can calculate the probability of occurrences. P is equal to m by n plus 1. So for this, m is 1, n is total number of data points. How many data points we have? I think 45. Yes. So basically here this is 1 by 45 plus 1, that is 1 by 46, and that is your probability of occurrences. P is equal to 1 by 46, and you will get the probability of occurrences is equal to 0.02 and something like that. Okay, and then if you reverse this probability 1 by P, that will give you the time period, that written period 46. Similarly, you can calculate this probability of occurrences for all these different discharge magnitude, and correspondingly you will also get the written period for that probability values. Okay, what is the advantage here? Now you can clearly say that what is the probability of occurrences for 1254 values, 1642 values, 16. So individually whatever values you have with your data set, now you know about the probabilities and corresponding your written periods. Okay, so now using this data you can make some sort of a plot. This is scatter plot, right? Scatter plot between written period and the Q max. Written period क्या है यहाँ पे? Which we have calculated t value, and what is your Q max value? That is your magnitude. Magnitude is what? These are the magnitudes like that. So you have already arranged it, and correspondingly you have the t value, and based on this t value you can basically plot the data points, okay, the maximum value and written period, and then you can basically calculate what is the value for, let's say you have got the equation here, y is equal to 712.44 natural log x plus something values. Here you can put the x value. What is x value? X value is your written period, x axis value. Okay, you put x axis value here in this particular equation, and you will able to get the written period for y values, and you will get the y values value, and that is basically corresponding to your written period. So you can put 100 year here, 100 value here, that is your 100 year written period flood magnitude, and you will get the y value, that is you will tell you about what is the 100 year written period flood magnitude, है ना, that you will be able to get from that particular equations. So this is basically sort of empirical way of dealing the data set, empirical way of dealing the calculating the frequencies from the flood data set. Of course, this is a very simplistic method, therefore it might also create some sort of errors as well when you are projecting for 100 years or 50 years flood frequencies. Therefore we can use the extreme value theory type 1 or type 2 or type 3 for minimizing that uncertainty in your projections. Okay, so we will first we will see this particular example through the Excel first, and then we will discuss about the later part of this presentation with some more examples. So I hope you got all the this data set. So I have already done this exercise. Maybe you can delete these columns and we can do this again. Okay. So you can jump to the sheet 4 where we have written these values. So this is sheet 4. We will work on sheet 4, even though I have already that is basically in sheet 1, sheet 2, sheet 3 we have done this analysis. So basically first of all we will remove this text thing, okay, because we do not need that. We know that year and QMax. So basically this is your data points, QMax, and we have to do some sort of ranking. So basically we can arrange this data from highest to lowest order. How do we do that? Okay, so this is how we can do that. Sort and filter, there is a one command here. If you open this command, there is a Z to A. Z matlab highest one, A matlab lowest one. When you click this particular command, here basically you will be able to organize this data set from the highest to lowest order. Now you can rank this data. So you simply put here 1, then 2, then 3. And then maybe you have to basically assign all the ranks for your whole column. So that is basically you can assign the rank of the data, that is 1, 2, 3, 4, 5, 6, 7, 8 till your 45. क्या चीज? अगर किसी ईयर में सेम आ जाए तो दैट्स अ गुड क्वेश्चन एक्चुअली. So maybe we can assign the same rank, right? Assign the same rank. हमें उसको सेम रैंक असाइन करना पड़ेगा ना, तो पीछे वाले का चेंज हो जाएगा, उसको हमें मैनुअली करेक्ट करना पड़ेगा. Is there any similar values? Yes, here. So maybe we can put here 15 also. Okay. There is one more here. So 29, this is 30, and here also. Okay. So there are 3 instances where we have similar values. You corrected this? Done? Okay, so once you have already corrected this rank, now you can calculate the probabilities. How do we do that? We can add equal to there, then we can write the formula. So we can, what is the rank? Rank is 1 divided by how many numbers are there? Total numbers 45. So that is 45 plus 1, m divided by n plus 1, right? If you click enter, that you will get the probability of the first event, and if you just you will get the probability of all the events. M is equal to, sorry, P is equal to M n plus 1. So M is your basically rank, n is your total number of data points. In our case it is 45. Are you able to calculate the probabilities? Done? Now you have probabilities. Now you can also calculate the return period. How do we do that? Is equal to 1 by this value D1, and if you click enter, you will get some value 46, and then you just stretch this whole column and you will get the value for all the values for that return period. Now you know the probability of occurrences of each extreme events and corresponding return period. Okay. Now you can calculate, you can make a graph which are correlating each other, that is your return period plus your magnitude, so that you will be able to show the relationship between return period and the magnitude. So insert, you can go to the insert data here, not like this. So this is a blank graph. Here you can go to select data, and here add data. What is the x value? X value of your return period plot. X value क्या होती है रिटर्न पीरियड प्लॉट की? जो रिटर्न पीरियड प्लॉट हमने डिस्कस किया था, नंबर ऑफ ईयर्स, रिटर्न पीरियड्स ना, रिटर्न पीरियड्स हमने क्या कैलकुलेट किया? सो बेसिकली रिटर्न पीरियड्स आर द दिस वन, इसको यस, दिस एक्सेस, लास्ट कॉलम, and then you are calculating the magnitude, which is your y axis. Y axis is your B column. Okay. Now maybe you can also do some sort of logarithmic transformation here, because generally you see that format axis, probability here logarithmic. Now you can see this curve is now more like a linear graph here. Once you have converted your curve into a logarithmic scale. So are you able to do that analysis? Is there any problem? Is there any problem? कोई समस्या है? हाँ, क्या समस्या है? गिर न जाए बस. हाँ? 45 है. तो कैलकुलेट करो. हो गया? प्रोबेबिलिटी आ गई. You got the probability. Return period आ गया. 1 by p. Now you can make the graph like that. So in x-axis you can इसको मैं इसे here. This is logarithmic. This is R. Display equation. So that is the equation we got. Y is equal to 729.3. This is ln x plus 31.297. So this is the equation we got. Now the question is, if I put x is equal to 50, what is the value of 50-year return period flood? Magnitude, y value. Can you calculate using the Excel? 2 to the power 2 to the power 4? No. So if you look at this graph here, 10 and 100 here, so you make this is 20, this is 30, this is 40, 50, somewhere here 50, right? Might be 2000. Okay, any other? But is it possible that कि 46 ईयर का जो रिटर्न पीरियड है उसकी वैल्यू है 3669 and 50 years is little lesser than that? It should be greater than, right? You can recheck your calculation again, क्योंकि रिटर्न पीरियड के हिसाब से तो बढ़ना चाहिए फ्लड, है ना? तो 50 years का जो है कैसे करेंगे कैलकुलेट, एक्सेल में कैसे करेंगे कैलकुलेट? तो बेसिकली हमें क्या करना है, हमें एक कोई सेल पे क्लिक कर देना है, ठीक है, और वहाँ पर इक्वल टू लगा देना है सबसे पहले, ठीक है. वंस यू एडेड द इक्वल टू इट विल बिकम ए फॉर्मूला. नाउ यू राइट द फॉर्मूला 729.31 multiplied by ln. ln is a function here. You click the ln this function, है ना, and now you write here the number. ln के अंदर क्या है, x. What value we are going supposed to add here in x? 50. 50 plus ये क्या आ गया, 50 plus 31.297. Okay, that is exactly correct. You are 2884.37. Yeah. Why it is like this? Now again there is another question. ऐसा क्यों है, ऐसा क्यों हुआ कि 46 ईयर की जो वैल्यू है इट वाज हायर, बट व्हेन वी yeah, so basically if you look at this particular line here, you can see here these values are little higher compared to your original value. So if you extrapolate this value, it will somewhere here, it is just touching your 3000, and therefore your values are little lesser than whatever you have already observed in the data. So there are some sort of errors or present in your the model data with your actual values, and that is your uncertainty. Might be 5-10% uncertainty in your return period estimate. Can you calculate 100-year return period flood? 100-year return period flood. अब x की जगह पे हमें 50 की जगह 100 रखना है. ओके, हाउ मच? 338984. This was your 100-year return period flood. Can we cross check this? So we can add here 100. Okay, so this is the value we got. So what I just demonstrated that suppose you have the extreme flow data set like this. Okay, you can actually calculate the probability. Once you have already calculated the probability P is equal to m by n plus 1, this relationship, you can calculate the return period T, which is T is equal to 1 by P. Okay, you can calculate the return period, then you can do some sort of relationship between your return period with your descending Qmax values, and you can make some sort of scatter plot between return period x-axis, and in the y-axis you will plot these the flood magnitudes. Yes, and that you will get some sort of log transformed scale, this chart, and you will get some sort of relations between y is the function of x. Function of x is what? X is your return period, y is your magnitude. Now you put x value, you will get y value. X की value हमने 50 रखी, तो that will tell you about the 50-year return period flood. If you put 100-year return period, it will give you the 100-year return period flood magnitude. You can also extend this analysis, 500 का भी कर सकते हैं, but sometimes extrapolating these values up to 3-4 times, it's not accurate, because as we move forward from the data points, the uncertainty will also expand. तो हमें पता नहीं है कि अगर हमने 500 का निकाला है तो उसमें कितने % अनसर्टेनिटी हो सकती है 100% अनसर्टेनिटी हो, है ना. तो बेसिकली दिस इज व्हाट बेसिकली वी कैन डू दिस सॉर्ट ऑफ एनालिसिस टू कैलकुलेट द रिटर्न पीरियड फ्लड मैग्नीट्यूड. अब क्वेश्चन ये होता है कि ये जो हमने अभी काम किया है, इज इट ओनली एप्लीकेबल टू फ्लड्स और सम अदर डेटा सेट्स एज वेल? वी कैन डू अदर डेटा सेट एज वेल. रेनफॉल एक्सट्रीम के लिए भी कर सकते हैं, टेम्परेचर एक्सट्रीम के लिए भी कर सकते हैं, और इसी के साथ साथ हम जो है अदर पैरामीटर्स जो भी हैं उन पे भी हम काम कर सकते हैं. ठीक है, it is clear to everyone now. If you can have another set of data set, you can use your data set and you can calculate the 100-year and 50-year return period floods and calculate the magnitude. Okay, this is very easy. It's not a rocket science, very easy tool. ठीक है. If you have any questions, you can still ask. You can also think about making some sort of function. Function कहाँ पे? You can think about making this kind of calculation in MATLAB as a function. Okay. If you make a function, you just have to input value, and that function will tell you about the probability magnitude. Now suppose let's say you have a region where you have 51 stations. ठीक है, 51 stations हैं हमारे पास, and for the 51 stations you have all these kind of the data, extreme value, extreme flow data. ठीक है. Now for the 51 stations you can do similar analysis. For each different stations you will get different relationship. Y और X का जो relationship होगा वो different होगा. क्यों different होगा? हाँ? Qmax सब बराबर रहेगा, रिलेशन डिफरेंट रहेगा. सो फॉर एग्जांपल लेट्स से अगर हम ये जो फंक्शनल रिलेशनशिप हमने डेवलप किया, ये नर्मदा को अगर हम एग्जांपल मान लेते हैं, यू जस्ट इमेजिन नर्मदा बेसिन. ठीक है, नर्मदा में कुछ अपस्ट्रीम एरिया होगा और कुछ डाउनस्ट्रीम वाला जो वहाँ पर हम मेजरमेंट कर रहे होंगे स्टेशंस. तो जो अपस्ट्रीम वाला जो स्टेशंस वाला एरिया होगा, ऑफ कोर्स वहाँ पे डिस्चार्ज की वैल्यू हाई होगी, लो होगी, कम होगी. तो अगर कम होगी तो वहाँ पर जो एक्सट्रीम वैल्यू आने की जो वैल्यूज़ हैं वो भी रिलेटिवली कम होंगी. मेरा कहने का मतलब ये है कि अगर हम नर्मदा में गरुड़ेश्वर या और भी नीचे वाले जो रीजन है उसमें अगर हमने मेजरमेंट किया तो ऑफ कोर्स वहां पे वैल्यू आएगी 2000, 3000, 5000 क्यूमैक्स, ठीक है। जो नर्मदा का जो अपस्ट्रीम वाला रीजन है वहां पर आपकी वैल्यू आएगी 250, 500, 1000 कुड बी द एक्सट्रीम कंडीशन, ठीक है। तो उस कंडीशन में क्योंकि एक्सट्रीम वैल्यूज भी आपकी डिफरेंट बदल रही हैं and correspondingly because of your climate change or climate conditions, hydrological conditions, geographical locations and topography, whatever, and also the location wise upstream and downstream conditions, so your functional relationship will also be different. So which means it is possible that in the upstream region your functional relationship is equal to y is equal to f1x, ठीक है, फंक्शन बदल जाएगा। एंड दूसरा जो तुम्हारा लेट्स से इफ यू इन द डाउनस्ट्रीम साइड योर फंक्शनल रिलेशनशिप विल बी एफ वाई इज इक्वल टू f2x। अब इन दोनों फंक्शनल रिलेशनशिप को जब हम बना देंगे, कैन वी कमेंट ऑन दैट कि व्हाट इज द फ्लड पोटेंशियल ऑन दीज डिफरेंट पॉइंट्स? मेरा सवाल समझो। तो दिस इज अ पार्ट ऑफ यू कैन थिंक अबाउट योर डेटा सेट, विथ योर डेटा यू कैन ऑल्सो प्ले विथ इट। Suppose there are two river basins which are exactly similar in size, aerial wise similar, climatic conditions different है, lithological conditions different है, hydrological conditions भी different होंगी, ठीक है। एरिया सेम है और हम उसको कंसीडर कर सकते हैं आपस में कंपेयर करने के लिए, ठीक है। ओके, सो फॉर एग्जांपल लेट्स से इन वन स्टेशन यू गॉट y is equal to f1x, in another station you will get y is equal to f2x. So this is, let's say, station number 1, this is station number 2. Okay, can you comment on both the stations property, which station has the higher potential to generate flood? इसका एप्लीकेशन क्या हो सकता है? इसका एप्लीकेशन ये हो सकता है कि हम ये बता सकते हैं कि ये जो स्टेशन है ना, ये फ्लड प्रोन है कंपेयर टू दैट स्टेशंस, रिलेटिवली मोर फ्लड प्रोन दैट वन। हाउ डू वी डू दैट? ये ना वायर इतना छोटा है, आई कैन नॉट गो देयर। अभी हाँ, so basically what we can do, I just give you some clue maybe, and then you can start thinking about the whole thing with your data points. So let's say this is your x and y plot, what we have done in the Excel. So this is your x value, this is your y value, this is your log transformed x value, and the relationship we got something like this, right? A linear scale, a logarithmic a plot, but because we are plotting in the logarithmic scale itself, that is looks like a linear plot. So it might possible that you will get this plot for S1, ठीक है, and you might get another plot for S2 because hydrological conditions are different. Area wise same, both the river basin can generate similar level of the discharge because area is same, but because of the climatic conditions, lithological condition, everything is different. Therefore these two things are different in flood potential. Now you can look at, let's say here somewhere is 10. Now you can draw a line here. Now you see that there is a one point here, another point here. So let's say this is your A, this is your B. So A is greater than B, which means at 10-year return period S1 पे जो मैग्नीट्यूड है that is greater than your 10-year return period of magnitude of your S2 station, which means the frequent events 10 years मतलब considerably we can consider as a frequent events, 10 years में आते हैं, ठीक है। In 10 years frequent events, the S1 produce more vulnerable flood conditions compared to S2. Similarly, if you go to some other let's say this is 100 here and you make a line here, that will also give you that this is, let's say, C and this is D, C is greater than your D. It means S1 is always greater than S2. But there are some conditions which can also be possible. There are some conditions which are also be possible. For example, so this is X, this is Y. Let's say this is S2, this is S1. In this case, it is also possible. In this case, let's say this is 1 here, this is let's say 10 here, and this is, let's say, 100 here. In this case, that is A and B, and this is not A, this is A is this, B is this, and this is C and D. So in this case, A is less than B and C is greater than D. A is less than B मतलब जो frequent event है S1 पे, that is actually lower than S2, which means in terms of frequent event, S2 has more magnitude compared to S1, right? But when we are talking about extreme events which are occurring very rarely, in that conditions we observe that S1 has more magnitude than S2. That is also possible. So this way we can do some sort of complex interaction between station wise, and we can think about what is the governing mechanism behind all these different processes. That can be also be done. So with this simple example, let's say you have multiple stations data in a river basin. We can do this kind of analysis, and then we can think about which station has more flood prone compared to the frequent event or moderately frequent event or rare events like that. You can just mark them, or maybe you can make some sort of spatial plot and highlight them like that, or maybe you can also calculate what is the percentage difference between magnitude wise, which station has more magnitude and like that. So this kind of the analysis you can do, and you can show based on that analysis. So that is what I wanted to add here, because we have done a very simple exercise. Now you can extend this analysis for more complex one. For let's say you take whole peninsular region. सारा peninsular region का मतलब जैसे कि कावेरी है, कृष्णा है, गोदावरी है, so lots of rivers there, and you can club it together, and you can think about making which river basin is more flood prone compared to the other. That can be done, right? अच्छा, इसमें एक और बात है यहाँ पर. There is one another thing is, sometimes this kind of analysis is very useful when you do some sort of normalization. क्योंकि कभी कभी हमें ऐसा होता है कि हम स्टेशंस को आपस में कंपेयर नहीं कर सकते. What is the reason behind it? Let's say there is a station in Narmada which is located upstream, है ना, and the area of that particular upstream region is very low, and there is a station in the downstream part where area is very high. तो of course जहाँ पर एरिया बहुत ज़्यादा होता है वहाँ पर फ्लड का मैग्नीट्यूड भी बहुत ज़्यादा होता है. एरिया इज डायरेक्टली प्रोपोर्शनल टू योर फ्लड मैग्नीट्यूड्स. ठीक है. So in that case maybe you can think about normalizing your flood values with your area. एरिया नॉर्मलाइजेशन. एरिया नॉर्मलाइजेशन करके भी हम जो है बहुत सारे स्टेशंस को आपस में कंपेयर कर सकते हैं, और कंपेयर करने के बाद उनके जो हिडन पैटर्न है उसको हम आइडेंटिफाई करके बता सकते हैं कि अगर नर्मदा में लेट से फ्लड आ रही है तो कौन सा रीजन एक्चुअल में रिस्पॉन्सिबल है, और लेट से कावेरी में, कृष्णा में, गोदावरी में अगर फ्लड आ रही है या बढ़ गई है, लेट से यू कैन ब्रेक दिस एनालिसिस फॉर मल्टी टेम्पोरल टाइम. You can break this analysis for 50 years and 50 years, and then you can compare कि जो पहला 50 year है उसमें कितना मैग्नीट्यूड आता था और जो नेक्स्ट वाला 50 years है उसमें कितना मैग्नीट्यूड आता है. Of course there will be a difference between these things also. So there are spatial analysis you can also do, and multi-temporal analysis you can also do, and you can compare your results with your ground availability or whatever the ground reporting is there. You can compare and you can just do very interesting work on this. So that is what we have already we have also done sort of multiple work based on this analysis. Not exactly this thing, this is a very simple one, but we have done some sort of gumball जो हमने पढ़ाया ना सुबह में एक्सट्रीम वैल्यू डिस्ट्रीब्यूशन फंक्शन, गम्बल, फ्री चिट और जो वीबल वगैरह है उसको हमने फिट करके we have done some sort of analysis in upper Ganga basin. If you go to my profile, that paper is already published in 2021 in scientific reports. So we have compared the different stations in upper Ganga basin, and we compared which of the stations are more prone to flood. And then we have also done some sort of flow duration curve analysis and sediment analysis like that, to understand the overall hydrological behavior of the upper Ganga basin, and we can compare with the neighboring. For example, upper Ganga is found by two river basins, Bhagirathi and Alaknanda, and Bhagirathi and Alaknanda we compared together which area is more flood prone. So I hope you got some research insights from this simple exercise as well. If you have any questions, you can ask. No questions? Whatever. Sink? Stream flow. This discharge data. So there is two options. In India there are two classification. One is the Ganga, Indus and all these river systems which are classified, because these rivers are coming from different countries and flow to the different countries as well, है ना. तो होता क्या है कि the CWC is considering those rivers as a classified river basins. There are few rivers which are not classified, for example peninsular basins which are originating from India, and they are going, these rivers are actually meeting with the ocean, so that is a classified. So those rivers basins which are classified or no not classified can be accessed by India WARIS portal, India WRIS portal. Okay, there you will get the discharge data. So there they have uploaded there, and you can download multiple stations data from there only. On the daily basis, yeah. अब ये जो है अलग अलग स्टेशंस के लिए अलग अलग है. फॉर एग्जांपल there are many stations which are functional after 1990, so probably you will not be able to get the data before 90. There are many stations which are operational since 1960s, so you will get the data from 1960. 30-40 is normal, you will get the data daily basis. So you will get the daily basis data, you can apply this whole algorithm or complex one, and then you can calculate the return period analysis for different reasons like that. And there is another way, you can directly request the data to the CWC. The Aditya Sarma ji aaye the aaj, so they have all the data set controlled with them. So basically for the classified river basin you can make a request, and they will also release the data with some terms and condition. अब मिलता नहीं है वो बात की अलग बात है. It will take time, but yes, they give the data set classified के साथ बस ये terms है कि you cannot share the data with anyone. If you have ordered the data, you have to keep your data within yourself. That is the one. Any other points you want to add, or you have any suggestions so that I can improve? No, everything whatever taught, you got the point. Bullseye. Very good. Okay. Okay, thank you so much for listening to me. Huh?